The diagram to the right represents a swimmer. The swimmer is capable to swim in a still water with a velocity v1 equal to 1 meter per second. And he aims his body directly across a 100-meter wide river. So this is 100 meters wide. The velocity of the current is 2 meters per second. And now we need to answer questions 37 through 39. 37 wants to know how much time it will take for the swimmer to cross a river. Well, first of all, when you look at this, you have to realize that we're swimming across a river, so it's not free fall. There's no acceleration due to gravity in this problem. So if we look at, we have velocity, we have distance, and we're looking for time. So if we know velocity equals a change in distance over time, we could say, all right, then time equals a change in distance over velocity, and the distance is 100 meters over a velocity in the direction that we're traveling of 1 meter per second. So the time would be 100 seconds. Another way of solving this problem is we're looking for time and we have distance. We could use the second kinematic equation. We could say in the vertical direction here. So we could say y equals y naught plus v naught yt plus 1/2 the acceleration in the y direction times t squared. All right, so we could say we're starting at a position of 0, and there is no acceleration in the y direction. So we would have y equals v naught yt, or time is equal to y over v naught y, and the y distance is going to be 100 meters, and our velocity in the y direction is 1, so we're coming up with the same solution, 100 seconds. Okay, number 38. How far downstream will he land? How far downstream will he land? Let's make some room here. All right, so we do have a time, and we're looking for distance. So now we can use the second kinematic equation in the x direction. X equals x naught plus v naught xt plus 1/2 the acceleration times in the x direction times t squared. Well, in the x direction, if we start at a position of 0, and again, there's no acceleration here in the x direction either, we're left with x equals v naught xt. The velocity in the x direction we said is the current, that's 2 meters per second, times a time of 100 seconds that we solved for problem 37. That would take us 200 meters downstream. Number 39, what is the velocity of the swimmer relative to the riverbank? All right, so we have velocity 1 in the going across the river, and we have velocity 2, the current, taking us downstream. So what we need to determine is the resultant velocity relative to the river, which would look like that. So the velocity across the river is 1, the current going down is 2. So to find this side, C, we'll call it, C would be equal to the square root of 1 squared plus 2 squared, which equals the square root of 5.